Hello viewers and my dear students. Welcome to one-dimensional problems analysis. This is problem 5, that is demo on one-dimensional bar analysis with two materials fixed at both the ends and with an axial load at the center subjected to thermal load. And here I'll concentrate on log file or macro management using Ansys Mechanical APDL Release 14. Please understand, in problem 4 I have already done this problem. The problem is this. Okay. This problem I have already done using Ansys Mechanical APDL Release 14. This has already been done. Nodal displacements I got it correct. Forces and stresses in each material I got it correct. Reaction forces also I got it correct. Now what I'll be showing it to you is another feature, that is macro management, macro file management or log file management. I'll be showing it to you. See here, at the end of problem 4, okay, I was at this stage. Can you follow? I was at this stage. See here, what I'll do, as you know here, I have already got the results and all that. See here, nodal solution. Okay. Nodal solution, displacement vector sum, you already got it. Okay, this is 0.22030. This is already correct. This you're recording. And reaction solution also, all items, you already got it. This is the thing, the summation of these two should give rise to 3 lakh newtons. That is, at node 1 and node 3, they are the supports. There the reactions are developed. The summation of this and summation of this will give you 3 lakh newtons. These are all the things of what I got. And even element table data also, SMISC1 and LS1, I got it. I have got this 11436, and that is the element 1, that is in aluminium, you have tensile stress. Okay, tensile force and tensile stress is this 12.707 MPa. Okay, and this is in steel, you have negative, no? It is compressive force and compressive stress 240.47 and all that. See here, I just want to concentrate here. These things you have already recorded. Now you see here, once we do this, log file it would have created. Can you see? What I'll do, no, I'll copy the entire log file. Okay, entire log file. Control C you do. Control C you do. That means it has copied. Then Control V you do in any, that's here in any Word file. Control V you do, the same thing gets copied. Okay, now as you see here, once you copy it here, you clearly know what exactly you've done in this problem. See here, it is one-dimensional analysis with axial and thermal load. This is the problem. And you see all others are 0. Structural analysis you have got. Structural is 1. All other things are 0. Thermal, fluid and all that 0, 0, 0. Okay, you understand in that way. It is, element is link 180. That is correct. Okay, I've just highlighted for making you to understand. Then, as you know, real constant 1 is 900. Real constant 2 is 1200. These things we have fit correctly. Okay, and also material properties data, first one is 70E3. Okay, and the coefficient of linear expansion is 23 e to the power of minus 6. That is also correct. And this is material property for material 2, for that is steel, 200E3, and coefficient of linear expansion is 11.7 e to the power of 9 minus 6. So whatever you have done, you see here, whatever you've done it in Ansys, in all these things would have been recorded in the log file. Okay, that is only I'm explaining now. Okay, that is only I'm explaining. All this in the log file only. I just copied the log file. As I just now told you, please understand again. Don't get confused. It is list log file. This I have copied. This I have copied. Okay, the entire thing I copied. And I paste Control C you put. You copied. Okay, Control C, copy. And then paste it in the Word. This is what, paste it in the Word, I got it like this. Okay, then once you get this, once alpha, that is 11.7 e to the power of minus 6, whatever we had done with that, then key point 1 is 0, 0, 0, key point 2, 200, 0, 0, key point 3, 500, 0, 0, and all that, and line. That means you are connecting line by 1 to 2, 2 to 3, and all that. Okay, then you see here, this is for 1, okay, that is for line the 1, this is attributes, sir. Attributes, that is, once you create 1 to 2 and 2 to 3, that is, we are attributing the properties. For line 1, it is 1, 1, 1, real constant 1 and material 1, and also that is, this is one ways, this is link 180, okay. And for the same way, for line 2, okay, we are attaching the properties, attributing the properties 2 to 1, real constant 2, material 2, and the one is of course link 180 only. The element remains same. Okay, in that same way, and then I have the size controls are done. I have divided both the lines into number of divisions, one and one only. That is 1 and 1. That is size controls, but is manual size 1 and 1. What I have taken, the same thing. Then I have meshed here. That is give, and after that I have saved. That also has been recorded. Okay. Then for item 1 and 3, these things will represent the nodes. For 1 and 3, all degrees of freedom I have made it arrested. That is 1 and 3, 0, 0, 0, all degrees of freedom arrested. For F item 2, 2, this is element, that is node 2 or key point 2. That means there I have given a force of 3E5. Everything has been recorded. Whatever I done by graphic user interface, all would have been recorded here. Okay, that is 3E5 has been recorded. Okay, and also since it is subjected to temperature load also, that is temperature on lines. Okay, that is 21 and 2 minus 2. That is for both the lines, the temperature is 40 degrees. That also done. Then finish solution. Okay, solve are done. Then under post processing, first is, as you see here, that is under post processing U component. That is first is reaction solution. This is R is reaction solution I got. Then another is that is displacement. One is reaction solution, displacement at different components. These are all the things. If you directly do this, you can write it as a program itself. These commands, if you know, you can write it as a program itself and get the thing. Then under E table, SMISC1, under E table, LS1. This is for member force, this is for member stress, and finally I got SMISC1 and LS1 I have done. Okay, this I tell you, this you just see what I do now. Okay, this I copy it now. Okay, now I'll copy it. I'll copy it, Control C I'll do. Okay, then you see here what I'll do. Okay, what I'll do here, I have to copy here. Okay, first let us say file or the whatever I've done, no, I'll remove it. Okay, see here, I'll remove this. Whatever I've done, you know already, we'll remove it. Okay. Okay, I'm reviewing everything. Now, there is nothing in the screen, nothing I've done. Okay, I'll replot, fit and all that I do. Nothing is there. Now what I've done, I have copied this, no, I have copied this, Control C. Now I'll go to this and I'll go to this, and that is, this is an Ansys command prompt. Okay, here I'll put Control V, you remember. That means I've entered here, then put enter, press enter. Okay, once you press enter, you see here what exactly is happening. All stages, whatever we are doing, all you are getting in stages. Solution is done. In that way, up to the last stage you are getting. See here, last one, what we had got it is this SMISC1, LS1 and all that, whatever you had got. That is member forces, member stresses and all that. First one is, that is aluminum has tensile stresses and tensile force, and steel has that is compressive stress and compressive force and all that. Everything, whatever we done. So easy it is. In that way, even here, this is 0.22030. I think you remember what we had done. This is the nodal displacement. At node 1 and node 3 they are fixed. There can't be any displacement. At node 2, 0.22030, what you had done, same thing you had got. And this reaction solution also, this and this put together, both in the negative direction, negative 1 and 3 at the supports you have. Okay, both negative it is. Okay, negative, because you have given 3 lakh newtons in the positive direction at node 2, at 1 and 3 you have the reactions developed. The summation of these two should give 3 lakh newtons only. In that way, whatever you've done, you'll get. See here, this material properties and all that, whatever we have done, you'll get it here. Okay. See here, close. You see here, this if you do, plot controls, style, size and shape. Okay, if you do this, you can see in 3-dimensional also. Okay, 3-dimension also you can see this. Okay, whatever you that. This first one is 200, that is 900 mm square. This is 1200 mm square and all that. Whatever is that, this you got. Okay, plot controls, style, size and shape. This make it off. Then plot elements. Plot elements. You go to the front view only. Now you see here, the advantage of this is, you see here, I'm just telling you, you can change anything here. Whatever I marked red, no, you can change anything. Earlier, 0.22030 was the displacement you had got. I had made the load, no, load is 3E5. Let us say I'll make 5E5. That means 3E5 means right now I have made 3 lakh newtons. I can change it 5E5. Okay, when 5E5 is done, naturally the load should be, that is displacements should be more, stresses should be more, all you can change. That means you change it here. Again, once you do this here, okay, again you copy. And I'm telling you, in the same way, you can change the key points also. You can change the real constant also. Okay, you can change the key points also, 200 to 500 and all that. You can change in your own way. Okay, but I'm showing you one change. Okay, let us say I have done this. I have changed it to, the load is presently not 3 lakh, it is 5 lakh newtons. Okay, 5 lakh newtons, control C I'll do. Okay, I'll go to this. I'll just do clear and start new. New file I'll create. It just say okay. I'll just fit it. Okay. Now what I'll do, there's nothing here now. Okay. I'll click here, Ansys command prompt. Control V I'll put. Okay. I'll put enter. Just see how exactly it is working. Everything, whatever I got, everything it is showing. Solution is done. Okay, now as you see here, the stresses have considerably increased. See here, this stresses, that is member force in first element, it has increased, stresses has increased, this has increased, compressive stress also, this also has increased considerably, this compressive stress when compared to other. Previously, it was 0.22030, no? Okay, now the displacement has become 0.39968 mm at the node 2. Okay, that means everything has been increased. Okay, in that way, you can make any change. Even here, you 5 lakh, no? This and this, whether you have done correctly or not, you add this. You applied 5 lakh Newton at the center, node 2. You add this and this, both are negative. Both, if you add together, you get 5 lakh Newton only. In that way, whatever we have done, that is correct. Okay. In that way, you see here, if you have any doubts also, list loads, forces on all key points you see. Now you see 0.5 into e to the power of 6 or 5 e to the power of 5 or 5 lakh newtons has been applied. Earlier it was 3 lakh. That's why changing has become very easy now. Okay. Changing has become very easy. That is why you go here, change whatever you want here and immediately and copy and paste in the command prompt and execute, the new results you get. That is why debugging has become a very easy feature here. Okay, did you follow? This particular procedure, you remember, I don't have to tell this in each and every problem, but I'll be telling, you just have to copy the log file and paste it in the command prompt. This problem, you take it as very important thing, because for the interview purpose and all that, you should say that you know graphic user interface, whatever we do. And also this macro operation, this what I just demonstrated, log file operation, also you should know. Okay, okay friends, thank you very much for watching. Thank you.